Today we are going to see the topic bubble sorting. What is sorting? Sorting is generally either arranging the numbers in an ascending order or arranging the numbers in a descending order. Suppose we take one example, which is if you are taking certain 10 to 5 to 6 numbers, if those numbers are not in the same order, we arrange the numbers in ascending or descending order. So we will see the next slide in the video. Introduction to sorting. Sorting arranges data in a particular order. As I said before, either it is ascending or descending. It helps in searching and organizing the data efficiently. So what the second point says is, if you are taking, as I said before, if you are taking 6 numbers, this sorting generally helps in searching the element. If the data is in ascending order, means we can easily search, right? And also we can also arrange the numbers in an organized way. So third point is some of the examples of sorting. As I said before, sorting marks, alphabetizing names, arranging books, etc. A simple question: which takes longer, sorting a shuffled list or nearly a sorted one? Let us see what is bubble sort. A simple comparison based sorting algorithm repeatedly swaps adjacent elements if they are in wrong order. The largest element bubbles up to the end after each pass. It continues until the entire array is sorted. So, in today's world, if you want to understand the bubble sort in a well-explained manner, so I will give one simple practical example. Imagine you have a bookshelf with books arranged in a random order. You want to arrange the books in an alphabetical order by author's last name. Let us see how bubble sort works in this practical example. First, we compare the what we do. First, we compare the first two books. If the author's name of the first book comes after the author's name of the second book, means we have to just swap. Next part, move to the next pair of books. Repeat the same process as what we did before. This process should be continued until you reach the end of the bookshelf. So, this practical example may help you to understand it in a better way. Let us explain the working principle of the bubble sort. What we are going to do here is very simple thing. Just we are going to give input as 4 or 5 elements. Not only 4 to 5 elements, we can give 8 to 10 elements or 9 to 11 elements, or it is your own wish as user defined. Just we are going to do is we are going to compare the first two elements. Just we are comparing the first two elements. Swap if the first element is greater than the second element. What I said, we are going to just swap the first element if it is greater than the second element. Similarly, move to the next pair and repeat the same process. After each pass, the largest element moves to the end. Repeat until all elements are sorted. So, here it is clearly mentioned that after each pass, the largest element moves at the end. So we have to look for every process as goes. So this clear step-by-step explanation is in next slide. But I will give one overview of this explanation with one small example here. Suppose we are taking one example, simple example. First number 4. 3, 2 and 1. What I said, compare the first two elements. I am going to compare the first two elements. What is here? Which one are the first two elements? 4, 3 are the first two elements. So 4 is at index 0, 3 is at index 1, 2 is at index 2 and 1 is at index 3. Totally we have taken 4 elements. Just we are comparing the first two elements 4 and 3. What we have to do? Swap if the first element is greater than the second one. 4 is greater than 3. Yeah. So we are going to swap 3 and 4. So it will be 3, 4, 2, 1. Next we are going to follow to the next pair and repeat the same process. So as we do when we compare 4 and 2, again we are going to swap. So once we repeat these steps, 4 goes to the last. As the fourth point is mentioned, after each pass, the largest element moves to the end. So in the first pass, the 4 goes to the last. Repeat until all the elements are sorted. So this will be one simple example. The overview. From the next slide, I will explain one another example with another step-by-step explanation written in this slide. I explained the simple example of a bubble sort algorithm in the previous slide. So we will see the bubble sort algorithm pseudocode. Simply I will explain. Don't think too much. I have given one example as 4, 3, 2, 1. I write it again. 4, 3, 2 and 1. Here we are going to keep I equal to 0 to n minus 1. This is for pass 1. This is for I iteration is for passes. I for passes. I is for pass. So I denotes P. So I am writing here in a short form as P. P for passes. So we are iterating this loop from I equal to 0 to n minus 1. N minus 1 means here what? This is 0, 1, 2, 3. We are going to give I less than n minus 1. N minus 1 means 2. Sorry, 0, 1, 2, 3. Here totally 4 elements. So n is equal to 4. So we are going to give 3. We start iteration I start from 0 and it runs till 0, 1, 2. So what J loop does we see? J equal to, we are assigning J equal to here starting element as J. This is J plus 1. Clearly see, this is J plus 1. And we are giving this loop till n minus 1 minus I. So what if array of J means ARR of J means array of 0. First J equal to 0, right? Array of 0. We compare 4 with 3. If 4 is greater than 3, right? As what we explained in previous video, if the first element is greater than the second element, we have to swap. So this third point we see if array of J is greater than array of J plus 1 means that is 4 is greater than 3 means we have to swap these elements. How will you swap? Here we have written simply as array of J, swap array of J comma J plus 1. Just think of one container. What we will do if you want to transfer anything like food or something else, we will take one our empty container and we will fill in that container and again we pass. So similarly, here we will take one element, one thing, one container which is named as 10. temp, temp. So we are taking here it as a container. We use here. Let's see how the elements get swapped in the next slides. Here, what we say is, as I explained one simple example in before slides. So here they are taking one example. What is that example? They are taking 5, 3, 8, 4, 2. How many elements is there totally? Let's see. As array 0, 1, this is 2, this is 3, and this one will be 4. So totally how much? We have 5 elements is there. Our aim is to sort it in an ascending order using bubble sort. We will see the step-by-step explanation of this sorting in the next slide. So what we will do here, so again I am explaining for your clear idea. What we will do here, we will first step what we will do, we will just compare the first two elements. If the first element is greater than second element, obviously 5 is greater than 3, we just swap here. As we proceed the same step to next process until then the arrays comes in a sorting order. As I said before, we have to keep one thing in the mind. That is, for every process of sorting, the largest element goes at the end. As I said before, what we are going to do is just we are going to see the pos 1 in this slide. What I said, they have taken on example. They are going to do step by step here. Compare. First, what you are doing is just comparing the first two elements. What is the bubble start rule? We will compare first two elements. If the first element is greater than the second element, we will swap. So here 5 is greater than 3. So we are just swapping here. So one swap, the element is 3, 5, 8, 4, 2. Next, as we have to follow this step to again and again. Same step. So again what we are going, we are comparing the first element and the second element. So 5 compared with 8. Obviously, first element is smaller than the second element here, right? So if first element is smaller than second element, there will be no swapping. So the element is written same 3 as it is 3, 5, 8, 4, 2. For us, first point is clear, second point is clear. Now we come to third point. We are going to follow the same step again. Now what we are going to do, we are going to compare 8 and 4. Which is bigger? As we know, 8 is bigger than 4. First element is bigger than again second element. We are just swapping. Once swapped, what is the thing? 3, 5, 4, 8, 2. Third point is simple and clear. Similarly, we are going to do the same step in bubble sort. So again we see we have what we should do now. We should compare this 8 and 2. Obviously here when you come here what you'll see, 8 is bigger than 2. First element is bigger than second element. So 3, 5, 4, 2, 8. For you, fourth point is also clear. So in bubble sort, as I said before, the largest element goes to the end for every process. So what the final point is, after pass 1, the largest element 8 is at the end. So in this array, in this sort of elements, 8 is bigger. So the largest element goes to the end at the pass 1. So now the fifth point is also clear for us. Let us see the again next process. What happens in bubble sort in the next slide. Now we come to pass 2. What we have to do here? the same process we did in past one, we are going to do it again. We are going to repeat it again. We are going to work on the first four elements because 8 is the biggest element that went to the last. So let us start working on the first four elements. What is the first step we have to do? Compare first two elements. We are comparing 3 and 5. Obviously here first element is smaller than the second element. So what we do? No swapping. So we are writing the same set of elements again. 3, 5, 4, 2, 8. So first 2 point is clear for us. Again, what we are going to do it again. Same steps. Again we are going to follow the same process. We are going to compare the 5, 5 and 4. Obviously here the first element is bigger than the second element. So the swapping here is done. 3, 4, 5 to 8. So third point is also clear. What we are going to do the next same process. Again we are comparing the 5 and 2. So 5 is greater than 2, we are swapping. So we get 3, 4, 2, 5, 8. What we have to notice is in the past one, the largest element 8 goes to the end. In past 2, the second largest element comes to the last. We have to notice it. Never forget this one. The second largest element goes to the end before end. Okay. So fourth point is also clear. Here it is clear that what I said, they are written the same thing after past 2, the second largest 5 is in correct position. So fifth point is also clear. Basically, keep one simple thing in the mind. When we come to bubble sort, in the past one, the largest element goes to the last. In past 2, the second largest element comes. In past 3, like that. As far like the same steps will be repeated again and again. Now we come to past 3. What happens in past 3? What we did in past 1 and past 2, we are going to repeat same thing in past 3. We are just working for the first 3 elements. What is the first 3 elements? 3, 4 and 2. Again, you do the same step. Compare first 2 elements. Obviously here 3 is smaller than 4. So no swapping is done here. We are writing the same set of elements again. 3, 4, 2, 5 and 8. So the first point is clear. Second point is also clear. In third point, what we are going to do? You'll see the same step before what we did. We are just comparing 4 and 2 here. Obviously, 4 is larger than 2. So swapping is done. Once swapping is done, 3, 2, 4, 5, 8. Third point is also clear for us. What I said, next largest element will go to the end in past 3. As I said before, another last element will come to the end. So what they have written in the last point, you will see after past 3, the third largest 4 placed correctly in its position. So again I am repeating what I said before. When you are taking the bubble chart, in past 1, the very largest element goes to the end. In past 2, another next largest element goes to the end. In past 3, another largest element goes to the end. So this is the main concept we should not forget here. Here we come to past 4. Let's see how we are able to work here. The same thing we are going to repeat what we did in past 1, past 2, past 3. We are taking first 2 elements, 3 and 2. As we are comparing first 2 elements, obviously 3 is greater than 2. Swapping is done. We are writing once swapping is done, we are writing the element which we didn't done before. 2, 3, 4, 5 and 8. What you notice here? All the elements are sorted in a correct order. Every element has retained its own position in an ascending order. So for us here, First point is clear. Second point is clear. We will look into third point. What is third point? After pass 4, array is fully sorted. What I said before. The same thing they have written. So now it is clear for you that how bubble sort algorithm works. I'll give one quick recap about the bubble sort. What is bubble sort? We are going to give some input. Just we compare the first two elements. The first element is greater than the second element. We are going to swap. We are going to repeat the same process or the same steps again and again until the element comes in the sorting order. One thing we have to keep in mind that for every process, for pass 1, the largest element goes to the end. For pass 2, another largest element. For pass 3, next largest element. As so on. So this is how the bubble sort algorithm actually works. Let us see what is there in the slide. As I said before, the final sorted array. We got the final sorted array. What is 2, 3, 4, 5 and 8, which is in a good ascending sorting order. Let us see the key observation. Each pass places one element in its final position. Comparison reduces with each iteration. Yeah. As we go to the next iteration, the comparison get reduced. First we are comparing, first in pass 1 what we are doing? We are comparing 2 with 3, next again 3 with, if 2 is, we are comparing all the elements with each other. As going to pass, as we are improving to pass, from pass 1 to pass 2, the comparison automatically reduces because the largest element goes to the end. So worst case, the case here is n minus 1 passes, which is the worst case of this bubble sort algorithm. Bubble sort visualized with moving bars helps better understanding. Let us clearly understand how the bubble sort get implemented using C program. So first step, hash include stdio.h. It is a simple step, that is nothing but it is a header file. We are just including in C program. Next, we are calling one function void bubble sort int array. Int array means we are just giving the input of array sorting, array elements. That is like 2, 3, 4, 5 we are given now. That is element. Int n means how many number of elements we are giving. So just we are giving some simple iteration like int I, comma j, comma temp. Look this temp. As I said before, it is one container used to swap the elements. First step, for I equal to 0, I less than n minus 1, I plus plus. This is for passes. We said no, pass 1, passes. For I is equal to p, for passes. Like pass 1, pass 2, pass 3, pass 4. Let j is for j equal to 0, j less than n minus 1 minus I, comma j plus. This is what j is for the elements comparison. J plus 1. We, as I said in bubble sort, what we will do? We will compare first two elements. If first element is greater than second element, we just swap the element. So this is for comparison. See, if array of j is greater than array of j plus 1, then we will swap. How we will swap? We will take one container and store the first element in that container, and we will get the array of j, the second element into the first one. Again, we will in the second element we will get the element in the container. This simple swapping works by using one container called temp. This will be very easy swapping. Like we are just swapping the two numbers using the one container. what we are doing here is, just understand simply. We are keeping one number into container and we are putting the number into the first container and we are getting the number from this second container. The simple swapping takes place in this step. So from the previous slide, we are clear that how bubble sort works and how it is get implemented. Simply bubble sort is very simple, that we are just comparing the elements with the one element with the another element next to it. Let us see the performance analysis of the bubble sort. Best case sorted array means, what is best case? Best case means giving the elements in a sorting order. So it is order of n. Average case we take is order of n square. Worst case means if the elements in descending order and we need to arrange the elements in ascending order, means it will be a worst case scenario, like it is an order of n square. So the complexity, say space complexity, is order of 1 for the bubble sorting algorithm. So first 4 point is clear for us. So first one is clear, second one is average case scenario, worst case scenario, and space complexity. This bubble sort algorithm is stable and in place of sorting algorithm. When we come here, we will see the application and real world analogy of bubble sort. We will see where are the places we use bubble sort in real world. So first point, what is that is, it is used for educational purposes and algorithm demonstrations. Like here, we are sorting the numbers. We are sorting the numbers. We need to arrange the students in ascending order and with their roll numbers, like that. Helps understanding sorting logic and algorithmic thinking. What we did here is, we understood how the algorithm get sorting in an ascending order using certain rules and regulation, and it also created some one algorithm, like an algorithm. It has some steps, so it created one algorithmic thinking. So first 2 point is very clear for us. What the third point says is analogy. Like soap bubbles, the largest element float at the top of the each pass. Like a soap bubble, the largest element it floats at the top of the each pass. This means what we did in bubble sort, for every passes the largest element goes at the end. For pass 1, the largest element goes at the end. For pass 2, second largest element goes to the next, like that. So what we till now what we see, we are we very much understood what is bubble sort, how it is works, how it is working with its rules and regulation, and how bubble sort is get implemented. We also seen the order of complexity of the bubble sort algorithm for its best case, worst case, and average case scenario. Real world application is also, we know how bubble sort is used in real world applications. So the related SDG for our topic is SDG 4, which is quality education. SDG 8, which is decent work and economic growth. SDG 9, which is industry, innovation, and infrastructure. So the conclusion of the bubble sort is simple but inefficient for large data set. Suppose we are giving one. Suppose take one example, like 18 to 20 numbers or 20 to 25 numbers. What we do, there will be lot of process will be there. We have to check the first element is greater than the second element. Like we have to do very large number of passes, and it will be very inefficient for us. For example, if you take some 50 to 60 elements, means it is very inefficient and we can't do that. We can't use bubble sort. So it is very good and workable thing only for some small set of elements or an average set of elements. Better alternative for this bubble sort is quicksort, merge sort, heap sort, not only these things, insertion sort, selection sort as well. From our video, it is very clear that how bubble sort works and how it is get implemented. So, thank you.